Hello, I'm glad to have you there. I want us to look at resonance in AC circuits, resonance in series RLC circuits, because resonance occurs in an AC circuit where we have a complete circuit, so the circuit comprising the inductance, the resistance, and the capacitance. Okay, so here we go. But before we move, please, if you have not subscribed to this channel, do well to hit the subscribe button, hit the like button, and at the same time, share this video with your friends. Now, let's go. Resonance. Now, the first thing we ask ourselves is, what is resonance? And when do resonance occur in AC circuits? Now, we can always say that, yes, resonance occurs in an AC circuit when the maximum current is obtained from such a circuit. Now, when, of course, in an AC circuit, you have maybe combined AC circuit. You have that current is equal to V all over Z. Of course, this current is RMS, V is RMS for a complete circuit. Now, this is your impedance. Now, for this, since we have our impedance here, resonance must, these two must come into play. For there to be resonance here, current obtained must be maximum. Then if you want to use the impedance obtained in an AC circuit must be minimum for you to see that, yes, resonance has occurred. So, in other words, we can say that, yes, resonance is said to occur in an AC circuit when the maximum current is obtained from such a circuit. Or you can say that resonance occurs in an AC circuit when the minimum impedance is obtained from such a circuit. Now, we can also say, this is a third definition, resonance occurs in an AC circuit when the reactance of the inductor becomes equal to the reactance of the capacitor. That means resonance occurs in an AC circuit when the inductive circuit equals the capacitive circuit, when LC becomes equal to the XC. Or we can say, of course, LC, reactance of the inductor, is 2 pi FL, while the reactance of the capacitor is 1 over 2 pi FC. Now, at that point in an AC circuit where 2 pi FL becomes equal to inverse of 2 pi FC, that is where we say resonance has occurred. So, having said these three definitions, in any exam, please feel free to supply any of these answers. The first one, when the maximum current is obtained from such a circuit, or when the minimum impedance is obtained from such a circuit, or resonance occurs when XL becomes equal to XC, or when 2 pi FL becomes equal to 1 over 2 pi FC. And of course, F is the frequency, L is the inductor. Okay, F is the frequency, L is the inductor, C is the capacitance in the circuit. To proceed, we say that, yes, the frequency at which resonance occurs is known as resonant frequency. Resonant frequency. Resonant frequency. And this resonant frequency is represented as F naught. Now, resonant frequency is defined as the frequency at which XL becomes equal to XC in an AC circuit. Or we can say that resonant frequency is the frequency at which maximum current is obtained from such a circuit. Or resonant frequency, you can also define it as a frequency at which minimum impedance is obtained from an AC circuit. We can also say that yes, resonance frequency F0 is expressed as 1 over 2 pi LC, 2 pi root LC, where L is the inductance in the circuit, C is the capacitance in the circuit. Now we have that here, resonance frequency F0 is measured in hertz. Okay, now we will take one or two questions, but then let us take a recap of what we have just said, that yes, resonance frequency is the frequency at which this is equal to this. Now, I will say that at resonance, maximum current is obtained. Therefore, at resonance, I becomes equal to V over Z, which is what we have written here. At this point, here, current is maximum here. The impedance is minimum at this point. Okay, let us take one or two calculations to add flesh to what we have just said. Okay, we have the first question here, and this question says, in a series LC circuit, the inductance and the capacitance are 12 Henry and 20 microfarad respectively. Calculate the resonance frequency of the circuit. Calculate the resonance frequency of the circuit. So, if we have this question, just calm down. Pick out the parameters given. Okay, let's go together. Solution. Now, those two parameters were given. They said the inductance and the capacitance are this and this. That means the inductor there, L, is 12 Henry. The capacitance C is 20 microfarad. Remember, this micro, you must convert it. It means something, and you must use it. Of course, it means 10 raised to power minus 6. So, which will give us that capacitance here is 20 times 10 raised to power minus 6 farad. Okay, and we are looking for the resonance frequency, F0. Now, we know that resonance frequency F0 is expressed as F0 equals 1 over 2 pi root LC, which will now give us, if we substitute, we have equal to 1 over 2 times pi by 22 over 7, or, of course, if you divide 22 over 7, it will give you 3.142, multiplied by the square root of L, we put L, 12, multiplied by 20 microfarad. 20 times 10 raised to power minus 6. And it will give us that F0 is equal to 1 over, now you take this first. If you take this, we'll have 2 times 3.14 to give us 6.284 multiplied by the square root of. Now we take this 12 times 20, and the 12 times 20 will give us 240. So 240 multiplied by 10 raised to power minus 6. 1 over, we take this 6.284 multiplied by square root of 240 times 10 raised to power minus 240 times 10 raised to power minus 6 will give us 0.00024. And of course, we have it 1, 2, 3, 4, 5. 240. Okay, 240. Okay. 1, 2, 3, 4, 5. Then the next one is 6. It's better you put it in ordinary form to help you do your punch or calculator. So which will now give us that F0 equals F naught is equal to, so let me write here. F naught is equal to 1 over now 6.284 multiplied by, now you take the square root of this value here, 0.0024 will give us 0.015. 0.0155. Now inverse, before the inverse, we have F naught is 1 over. Now 6 times this value, if you multiply it by 6.284 multiplied by 0.0155, it will give us 1 over 0.0974. Inverse of this, which will give us 1 over 0.0974, will give us 10. That means the F naught there is 10.3. Therefore, F naught is 10.3 Hz. That is the resonant frequency. So, we said in this series LC circuit, the inductance and the capacitance, given that they have these values. Now, the resonant frequency is the frequency at which XL becomes XC. Is this. Now, we'll take more questions. Now, we have this question here. Now, we have the question is taken from a circuit. Now, this AC circuit has R, C, and L. And then we have the AC source here, which will give us the AC source is equal to, of course, this is amplitude current times sine omega t. For details on how we got this, please see the link in the description below. Now we have, in the AC circuit above, the resonance frequency is that. Just using this circuit as a guide, calculate the resonance frequency. Now, how do we find the resonance frequency? Each of these will be the correct answer. Either this or this or this or this. Okay, so solution. We have from here that, yes, this, of course, we know that the resonance frequency is inverse of 2 pi square root of LC. Which will give us, from here, we have that F naught is unknown. Now, C is given to be 5 microfarad. 5 microfarad. Therefore, we say C is 5 times 10 raised to the power minus 6 farad. That is what it is. Now, the next one is the inductance. The inductance L is given to be 8 millihenry. Now, milli means divided by 1,000 or times 10 raised to the power minus 3. However you want to take it. Why this one is divided by 1 million. So we now have that 8 times 10 raised to the power minus 3 Henry is our inductance. Now, if we substitute into this, we have that F naught is equal to 1 over 2 pi. Of course, from here now, because it is an BJ equation, pi is given. Because pi is given there, you don't need to substitute the value of pi. You multiply by pi here. So, which will now give us roots L. L is 8 times 10 raised to the power minus 3 multiplied by C. C is 5 times 10 raised to the power minus 6. Now, since it's like this, we have F naught is equal to 1 over 2, of course, 2 times pi is 2 pi, multiplied by the square root of 8 times 5 is 40. 40 multiplied by 10 raised to 1. Of course, this is, you apply a lot of indices here, where you multiply the basis and add the index number. So add the index number, this and this will give us minus 9. And of course, 40 times 10 raised to 1 minus 9, I will jump a step here. F naught is equal to 1 over 2 pi multiplied by, now I want us to take the square root of 40 times 10 raised to the power minus 9, or 4 times 10 raised to the power minus 8, however you want to take it. And times, then if we take the inverse, because we're not taking the square roots. If you take the square root of 0.000, 1, 2, 3, 4, 5, 6, 7. If we take the inverse or square root of this, to now give us 2 pi times 0.0002. Now, which will now give us F naught is, at this point now, we can also split it as 1 over 2 pi multiplied by 1 over 0.0002, which will now give us, as we will take the inverse of this and leave this, we'll now have 1 over 2 pi multiplied by, if you take the inverse of this, 1 over 0.002, I will have 5,000 here. So F naught will give us 1 times 5,000 will give us 5,000 all over 2 pi. And of course, at this point now, 2 can divide here to give us that F naught is equal to 2 divide 5,000 give us 2,500 all over our pi here. So this is our answer in heads. And of course, the answer is 2,500 pi, 2,500 over pi heads, which corresponds to option B. So option B is our correct answer. Now, we will still take another question. Okay, we have this question. The question says, a capacitor of capacitance 20 times 10 raised to the power minus 12 farad and an inductor are joined in series. The value of the inductor that will give the circuit a resonance frequency of 200 kilohertz is dash. Now, if you look at the options are in fraction. So when options are in fraction, we take them as they are. Okay. Solution, we have, from this, we have that the capacitance C is 20 times 10 raised to the power minus 12 farad. Now, the value of the inductor is not given because he said here, what is the value of the inductor that will give the circuit a resonance frequency of? Now, the resonance frequency is 200 kilohertz. And of course, kilo means 1,000. Therefore, F naught is 200 times 1,000, which will give us 200,000 hertz. Okay, we proceed. Now, how do we solve this problem? We recall that since this one will have F naught, I will have a C. L is not given. And of course, if we should use F naught is equal to 1 over 2 pi square root of LC, it will not work because we will still, we can still solve it using this. Now, they said the resonance frequency is given what is the inductance of the inductor that will give it this resonance frequency? Okay, we said also at resonance, XL is equal to XC at resonance. Now we know that yes, XL is 2 pi FL, while XC is 1/2 pi FC. In other words, we can equate these two. So if we equate these two, just here and here, without this, because we're not given the reactance of the inductor. So we can now have 12 pi FL is equal to 1/2 pi FC. Now, if we have this, we can make L the subject from here. If we make L the subject, we cross multiply. If we cross multiply 1 times 1, which will give us 1 times 1 is equal to 1, which will give us 2 pi F times 2 pi FC will give us 2 pi F, the whole of this, L multiplied by 2 pi FC. Now we're looking for L. Make L the subjects. We could have used this, but if we use this, for us to take care of this, we need to go round and round to get this. So this one is most preferred. Now we have, if we make L the subject from here, L will now give us 1/this one, all over the whole of this is here. 2 pi F multiplied by 2 pi FC. So we can now substitute. So we have that L is equal to 2 times pi will give us 2 pi multiplied by F. F is 200,000 times 2 pi times F again. F is 200,000 multiplied by C. C is 20 times 10 raised to the power minus 12. Now we go. We have L is inverse of. Now I will multiply out everything we have from here to here, which will now give us, of course, 2 pi. We can substitute the value of pi, which is 3.142, and multiply it by 2. So we have 2 times 3.142 multiplied by 200,000 multiplied by these two again, 2 times this pi 3.142 multiplied by this 200,000, which will now give us 1.5, just from here. I've not included this one. This one has a negative sign. 1.57 or 1.58, please. 1.58 times 10 raised to the power 12 multiplied by, now I can now bring this one 20 times 10 raised to the power minus 12. This, of course, this one and this one will go. And if they leave from there, we now have 1.58 times 20. 1.58 multiplied by 20 will give us 31.6. Therefore, and of course you can, because this one is up to half, we can round it up, approximate this to give us 32. Therefore, L is inverse of if we approximate this one to give us inverse of 32 Hz. Sorry, Henry, please, but this is L. Henry. Now, this is our final answer. Okay, this is where we draw the lesson to an end. Feel free if you have questions, feel free to ask me. You will see my WhatsApp line there. WhatsApp me directly and I will be able to answer you. Please, if you have not subscribed to this channel, please do well to subscribe to this channel so that the moment I drop subsequent lessons, you will be notified. And mind you, I'm always available. Ask me questions.